Hello, welcome. In this short video, let us look at an example illustrating how to construct the probability mass function of a discrete random variable in the case of multiple independent trials. So, for simplicity, let us assume that there are two independent trials, each with a probability of success of Pi. That is, we have trial 1 and trial 2. It is trial 1 and trial 2. The probability of success for trial 1 is P1 and probability of success for trial 2 is P2. So given this information, how do we construct the probability mass function of a random variable which basically counts the number of failures? That is, in this case, since there are only two independent trials, the number of failures or number of possible failures is a random variable and it has the following possible values. That is, there can be no failures, that is the value of the random variable x is 0, or there can be just one failure, that is value is 1, and there can be both the trials we see a failure, that is 2. This methodology nicely fits examples where you are dealing with construction of an assembly with multiple components. That is, for example, if you want to assemble two components and the construction of the individual components is independent of each other, then you want to find the probability that how many components will fail in the assembly. Then this kind of approach is very much applicable. So now we have the range of the random variable x, that is the values change from 0 to 2, that is where 2 is the number of trials or number of components in a assembly. Now we want to construct the probability mass function. That is, for probability of x equal to 0, we have only one possibility, that is both of them, but that is succeed in both of the trials, that is or in an assembly both of the components work. That is, we have probability of x equal to 0 is 1 or P1 into P2. That is, probability that none of the components fail or probability that both the trials are succeed is equal to the product of the probabilities of the success for each trial, that is P1 into P2. For probability of x equal to 1, that is only one component fails. That is, either we have 1 minus P1 into P2, that is the first component fails, and in the other case only the second component fails, that is first component succeeds, P1 into 1 minus P2. So this is the probability that only one component fails. The next value is probability of x equal to 2, that is both the components fail, should be equal to 1 minus P1 into 1 minus P2. Therefore, the probability mass function is given by, for values of x equal to 0, 1 and 2, the probability mass function P of x equal to k, is where k is equal to 0, 1, 2, is given by P1 into P2 for x equal to 0 and 1 minus P1 into P2 plus 1 minus P2 into P1. And finally, for x equal to 2, we have 1 minus P1 into 1 minus P2. So that's the probability mass function. Clearly, this methodology can be extended to the case where we have multiple trials, especially with a number of trials greater than 2. And in that case, the value of the random variable changes from 0 to the number of trials. And in the case where the probabilities of each trial, that is the probability of success of each trial is constant and is given, that is when P1 equal to P2 is equal to P3 is equal to Pn and so on is equal to a given value P, then the random variable becomes a binomial random variable. That is, when P1 equal to P2 is equal to and so on equal to Pn, wherein is the total number of trials is equal to a constant P, then the probability mass function is basically a binomial distribution and the random variable is a binomial random. That is, x is a binomial random variable with the parameter P and N. Thanks for watching.